Bismillahirrahmanirrahim. So the next unit we have of chapter 1 is 1.3 compression. Compression of actually it's the compression of the files that we usually download or we usually send to other devices. Okay. So we will begin with the syllabus. Hydrogen should be able to show understanding of the need for and examples of the use of compression. Okay. So we are going to understand this. Okay. First of all, why do we compress a file? Okay. First of all, you need to understand how compression is done. Okay, compression is reducing the file size. Okay, in a way that the data is not affected. You okay. In a general case, data is not so well affected. For example, if I download, I'm just recording this video and I have a lot of background noise. Okay, and lots of noise that you cannot hear. Okay, so if I compress this file, okay, so first it may somehow compress the it may compress the file and reduce the file size. Okay, how will it do that? We will be learning some ways. Okay, but we just need to understand that compression reduces the file size. Okay, how why do we reduce the file size? Like for example, if for maximum quality we'll be having the maximum size. Okay, but why do we want to reduce the file size? Okay, first of all, when they ask you, the camera asks you why to compress, why should a file be compressed? Okay, so that the file size is reduced. That is a general thing. But why should the file size even be reduced? So that it requires less storage. Okay, for example, if uh, I have storage of three I will have storage of 8 GBs. Okay, so if I have better quality less videos and lower quality more videos, okay, so and if I want to store more videos, so I will have to decrease the quality because we'll be learning that I made a table here. Okay, anyways, that as soon as the size increases, the that decreases. So this is the rule that we are going to stick to, that as soon as the quality increases, that we had already discussed, it is for remembrance. As soon as the quality increases, the the file size also increases. Okay, so for example, if we have uh, a video or a picture of some more quality, okay, and so it will occupy more, the file size will be more and it will occupy more storage. Okay, so we need to remember this as well, that if we need good quality, for example, if we are sending uh, making a website. Okay, for example, they give you suggestion in the exam, so you have to take care of that. Then if you are making a website, okay, so for that you need very accurate and very precise and very good quality of data. Okay, so you'll be using there this there you'll be using compression of less intensity. Okay, so you'll be seeing both of the intensities and seeing what the syllabus demands. So understanding of the need, we already discussed why do we need it. Need it. Let's recap it. Okay, so if the file size is smaller, so what do we do? The lesser the file size is, the quicker it will be downloaded. Surely, for example, I have the data of 8 MBs per second, for example. Okay, it's the internet speed is. So I can in 1 second, okay, I can download a file of 8 MBs. Okay, but if I have a larger file of 16 MBs, so it will take me 2 seconds to download that. Okay, that's how faster download happens with less file size. And the less bandwidth required. For example, if I had 16 uh, file of 16 MBs, okay, and I needed to download them in 1 second. So I would need more bandwidth. I would need more passage to allow that. Okay. So what is bandwidth? We'll discuss that as well. But for a basic understanding, you can say I would need internet of 16 MBs per second so that I could download the 16 MB file in 1 second. So these are the reasons we would, So the next thing is example of the user compressor. We just had an example of the downloads. Okay, and the example, and usually they give the example themselves that will be. doing analysis on that example. Okay, and when we practice that, we'll get to that. We need to worry about that. Show understanding of the lossy and lossless compression and justify the use of method in a given situation. Okay. So loss, what is lossy? Okay. This is the most important topic in this compression. What lossy is? Now listen. Lossy the method compression that is there, compression method that reduces the file. Okay. Lossy as well as lossless. But the difference is in lossless file compression, the data that is compressed, okay, that is not lost. For example, it is by some algorithm, it is compressed in a way that do not lose the data, but actually reduces the length of the data. Okay, we'll be learning one example. But what lossy does, lossy removes some quality, removes some sound. As I told you, there's a background noise behind me. Okay, so if I compress it with this, okay, with the lossy compression, so that voice would be reduced. And second thing, for example, the humans the hearing range is from 20 hertz to 20k hertz. Okay, so any voice out of this range would be eliminated because that is not needed. So like this, it eliminates a lot of, you know, data and all, reduces the file size and lots of quality. So in the lossy compression, that quality and file size both are reduced. Okay, so it's compressed state. The comparison that we have to memorize, so that we can memorize. So one compression that we are required to know is something show understanding of how a text file, bitmap, vector graphic, and sound file can be compressed. Okay, so we have to understand this RLE. What is RLE? Okay, how can you apply it to text file? How can you apply it to bitmap, image, vector graphic, and sound files? So we look at example of text file, bitmap, image, and vector graphic. How are they, you know, compressed with rel length encoding? Well, exactly rel length encoding. So if we understand from this, okay, the length, the some similar quantity run for, we encode that. For example, if I have, let's see in this example, let's take this example. I have 10 times A return, 7 times B return, 3 times C return. Now, for example, if A took, if we are using ASCII code, if A took 8 bits, so it would be 80 bits here, okay, okay, 80 bits, 8 bytes here, 10 bytes here, and then 7 bytes here, then 3 bytes here. So this would store a long text, okay. So we encode that. We see the number of times this A is there, write that number and write what is run. Okay, number 10 times A run, 10 times A, okay, 7 times B, 3 times C. Okay, so we just write it. Now it would take, it is 6 letters. Okay, so it would take, but 6 into 8, so it would take 48 bits. Rather than that would take around 20 bits, 20 bytes. Okay, so we have reduced from 20 to 6 bytes. Okay, so that is a almost we have that we have reduced our file size to from 20 bytes to 6 bytes. So that is a good of more than 30% of the compression. Okay, so let's see, for example, let's see what is the actual definition of RLE. If they ask you in the exam, so you are going to write this. RLE is a lossless file compression. RL is a lossless file compression method that replaces the repeated sequence. Okay, I just forgot it. Repeated sequences of data with one copy and count of data. Okay. The compression method, for example, we are going to. This is the thing. It's going to be lossless. Okay. That replaces repeated sequence. For example, we have a repeated sequence that is going on of A. The same repetition we are having repetition of A character A. Okay, so of that replaces that with one copy with only A and count of the data, 10 times. Okay, so this is a definition. So this definition defines the method and explains the method as well. Okay, So if you memorize this information, you are going to remember the method, how to do or what to do. Okay. Now, if they ask us for the text is done. Okay. Then let's apply this definition on the image as well. Okay. This image we have, for example, okay, it's kind of hard type. Okay, and the lossless file compression method that replaces repeated sequences of data. At that I didn't, instead of data, I didn't write character or letter. Okay, I wrote data. So for example, if we have three white colors, okay, three whites. So we white one, B1, white 3, B1, white 1. Okay, then B3, white 1, then B3, then B7, then W1, B5. Now instead of storing so many, the instead of storing all the shades for this, okay, we are only encoding this and replacing the data of this with one copy and count of that data. For example, here it is W3. So the copy of data is W and count of the data is 3. So it becomes W3. For example, here B7. Okay. So B is the data is the copy of that, one copy of repeated data, and 7 is the count of it. Okay. So this is not so complex thing if they ask in the paper. So it will be very simple to do it. Okay. For example, they can give you an image and you are just going to encode it down. Okay. We'll practice it. No need to worry. Okay. Then they said about the sounds. How will you do of the sounds? The lossless. Okay. So for example, I have uh, I have one. I just make a sound. Okay. That is. So an example of it would this, for example, I just make sound so this when I'm saying, okay, so it is a particular sound that is being repeated. So for how many milliseconds or how many nanoseconds or how many seconds I'm repeating this sound, okay. So one count of the one for how much I'm using that and what sound it is it, okay. So that should be recorded. So this lossless is not so lossless sound file is not so important and not so discussed, okay. But they just mentioned that we should be very aware with this, okay. But usually what do they do when they ask you? So you have to start describing it that the sound compression uses music perceptual shaping. What do they do in that? They already discussed that delete sound that are outside human range. Okay, they also discussed what is the human range, 20 hertz, 20 kHz, delete background noise, and decrease sampling resolution. Okay, so these small steps could be taken to decrease the sound file of the to find the reduce the sound file size. Okay, so we understood the need and examples of use of compression. We just did with the example of image text, the image, and the sound. Okay, so understanding of lossy and lossless compression and justify the use. For example, they say you a code is being sent, okay, and the I'm sending a code to my friend, and then I have to use a compression technique. So what compression, which compression I would use, lossy compression or lossless compression, that to send the data. Okay. So surely now code is such a thing that is written that has its specific syntax, and if you miss any of the thing, the code starts generating errors. Okay. So I cannot compromise. I cannot commit to have intend to have lost any of the data. Okay. So I need to use lossless. Okay. Then this code argues. For example, let's say you went to the beach, okay, and then you capture some of your pictures, and now you need to send it to your friends, okay. So what are you going to do? Which one are you going to do? So that's not important. So important. Those pictures will not be so important. So you may use lossy, okay. And the same way we'll make examples. So we are going to do this part especially. We have already discussed it good enough, but we'll more practice it in the papers. Okay. And show understanding about text file, bit by image. This is all we have done. So this chapter 1.3, 1.3 is also done. Chapter 1 comes to an end with this. Channel communications will soon come in that too. Allah Hafiz.